Hi, Algebra 1A students. Welcome back. We are now working on Lesson 8, and this is the third lesson in project number 2. There are 5 questions for this lesson's project, so we need to jump right in. A monkey named Mac was kidnapped from the Uptown Zoo. Luckily, Mac has a microchip that tracks his real-time location. The police discover that he is traveling north of the zoo on Windsor Drive in a linear pattern, thus at constant speed. Use your knowledge of writing equations in point-slope form to help rescue Mac and catch the kidnapper. Okay, so the first thing that we need to talk about here is the fact that the point-slope form of an equation looks like this. It is y minus y1 equals m, which is slope, times x minus x1. And we can go ahead and put these in parentheses if we want. The easy way to remember this is that it's simply the equation for slope rearranged. So if you remember, slope equals m equals y2 minus y1 over x2 minus x1. So if you can remember that, then you can just take this quantity and multiply both sides. So m times x2 minus x1 equals y2 minus y1 over x2 minus x1 times x2 minus x1. So what I did here was just simply multiply both sides by x2 minus x1. They cancel out on the right, and I'm left with this point-slope form. So if you can't remember point-slope form, just remember that it is the rearrangement of the slope equation. Okay, so knowing that, we are now asked to come up with the point-slope equation for a couple data points here. Mac's location was 7 miles away from the zoo at 10 minutes, or a sixth of an hour, and that was after he was kidnapped. Okay, and then 20 minutes later, or a third of an hour, he was 12 miles away. So let's just graph that really quickly here. And we can see that if we put time on the x-axis and distance on the y-axis, because distance is a function of time here, we will see that at 10 minutes, he is 7 miles away, and at 20 minutes, he is 12 miles away. Okay, so gonna look something like this. It's probably not exactly like that, but it's close. Okay, so what we need to do here then is to figure out the slope between these 2 points. So the first point is at 10 and 7, and the second point is at 20 and 12. So let's go ahead, and I'm also going to just change this. This is 1/6 of an hour, and this is 1/3 of an hour, which is the same as 2/6 of an hour. So let's work in hours instead of minutes here. I think that'll make our lives a little bit easier. So remember, slope is change in y over change in x, which in this case is 12 minus 7 over 2/6 minus 1/6. This becomes 5 over 1/6. And if you're dividing by a fraction, you simply have to multiply by the reciprocal. So in this case, slope equals 5 times 6 over 1, which is 30. 30 over 1, but that's the same as 30. So I can narrow down my choices here to have any of the answers with a slope of 30 will work. Okay, so now I need to decide then which of these equations I can potentially use. So I need to rewrite my coordinates here. So my first coordinate is going to be 1/6. Okay, that's my x value, and my y value there is 7. Okay, and my second coordinate is at 2/6 or 1/3 and 12. Okay, in the point slope equations that I use, I can only use 1/3 with 12, and I can only use 1/6 with 7. I can't mix up 1/3 with 7 and 1/6 with 12. I have to keep it within the coordinate that works here, okay? So I know I've got to have a slope value of 30, all right? And if I say x minus 1/6, I have to say y minus 7, okay? If I say x minus 1/3, I have to have y minus 12. And this one has the wrong slope. So none of these work, okay? So let's see, y minus 7 and x minus 1/6. This one would work because it matches here, okay? Y minus 12 and x minus 1/3. This one matches here. So that will work. This has the wrong slope. Okay, so these two equations will work. That was kind of a long one. But those are the two that will work for this. Okay, so what does the slope of the line represented by the equations we selected in the previous, okay, so what is the slope? So we know full well that that slope is 30. We solved for that. And then what does slope represent? Well, slope always represents a rate, okay? In this case, the y-axis represented distance, the x-axis represented time, and the rate or the speed that the monkey was traveling is represented by the slope, okay? Okay, so after the police track the monkey and his kidnapper for a while, the linear pattern changes. After 1 hour, the location is 32 miles away from the zoo. But after 70 minutes, or 7/6 of an hour, the location is still 32 miles away. Okay, so now we're kind of in a new scenario here. And so after 1 hour, he's 32 miles away. But then after an hour and 10 minutes, 1 hour, 10 minutes, okay, he's still 32 miles away. So we've got a horizontal line, which means that our slope is 0, okay? So basically, in this case, our y value is not going to change, okay? But our x values are going to change. So when we write this in point slope form, it's going to look like y, let's see, y minus 32, because those are my two y values. I have to do that one, equals 0 times x, and I can either choose 1 hour or I can choose 7/6 hours. So I'm going to do 1, x minus 1. Okay, so my distance does not depend on time in this situation. In this situation, the distance is going to be 32 minutes unless they move further away. When my slope is at 0, it's always going to be 32 miles. I think I said 32 minutes. It's always going to be 32 miles away as long as they're traveling, as long as they remain at that either that spot or within that radius. So there's two things that could happen here. They could be not going anywhere. They could just be staying in the same place, or let me get my pen back. Or they could be going around in a circle, okay? So either of those things would work in that 32-mile radius circle, but it's probably more likely that they just didn't go anywhere. Okay. So let's scroll down here. The monkey and the kidnapper start changing positions again after a little while. They were still at the 32-mile mark after 90 minutes, or 1.5 hours, or 3/2 of an hour. But then they started to travel 50 miles an hour. In order to help the police catch up to the kidnapper, arrest him, and safely return back to the zoo, write an equation in point-slope form of the line that represents this situation. Okay, so we're going to do kind of the same thing. And okay, so 3/2 of an hour, okay, because this is our x-axis is time, and our y-axis is distance, okay? They were still at that 32, okay? But then they travel at 50 miles an hour. But what we're not told here is the next point. But we don't need to know that. We have our slope and we have 1 point. So if you just have slope and 1 point, you can still fill in your point slope equation. And it becomes really handy. X minus x1. So this is going to look like y minus 32 equals 50 times x minus 3/2. And we chose the 3/2 because we're dealing in miles per hour, so we wanted to do 3/2 of an hour. Okay. All right, so last question here. When writing equations in point-slope form, there are an infinite number of ways to write the equation because there are an infinite number of points in the line. Okay, given 2 points in point-slope form, explain how you can determine whether they represent the same line. Okay, so the way that we could determine whether or not they represent the same line is by solving for b. Okay, if we can rearrange, like let's say the equation that we have right there, the y minus 32, if we can rearrange that into slope-intercept form and solve for b, we can determine if we're dealing with the same two lines, x minus 3/2. Okay, so I would have to multiply through, and I would say y minus 32 equals 50x minus 150 over 2, because I'm multiplying 50 by 3 and dividing them by 2 is 75. Okay, so then if I add 32 to both sides, I will get y equals 50x, let's see, 43, minus 43. So minus 43 is my b value. It's where this particular line would cross the y-axis. And if they are the same line, they will have the same slope and the same b value. Okay, so you can use this very example and say you need to solve for the slope and the b value of both lines to determine whether or not that they're the same line. You can have two lines that have the same slope but don't have the same b value, and they will not be the same line. For example, we could have a line with a b value up here and the same slope. It's not the same line. It has to cross in the exact same place. So I hope that makes sense. I've run out of time. Thank you for watching, and I'll look forward to your answers.